Today's lesson is over section 2.8, where we'll talk about the first and the second derivative of the original function and being able to sketch that. So when we're looking at the first derivative, remember we're talking about the slope of the original function. So when the first derivative is positive, that means we're increasing for the original function. When the slope is negative, that means we're decreasing for the original function. If we're looking at the second derivative, that's actually going to talk about concavity. So the second derivative, when it's positive, that means that the function is facing upward or concave up. When we're looking at the second derivative and it's negative, that means it's concave down. So if you want to think about a parabola, that's probably a great way to start. So here are two ways that we can be increasing for a function. So obviously they both have a positive first derivative because they're going up. But now, if you think about how they're increasing or how they're positive, so on the left, you're increasingly getting higher and higher. So that means your slope of the first derivative is getting steeper or more positive. So that means we're making a graph that is concave up. So that means the second derivative is positive. If we are starting to slow down the increasing value, so we're heading towards zero, that means the slope of the first derivative is starting to become negative. So then that means that your second derivative is actually negative as well. So that means that we have a concave down function. Now there are also two ways of decreasing. So they both have a negative first derivative, but the one on the left, we're starting to decrease more and more and more. So that means that that slope is getting more steep. So because the slope of the first derivative is becoming more negative, then that means that our second derivative is going to be negative as well. So then we're concave down. The one on the right, though, your slope is actually increasing for that first derivative because you're starting to get closer to zero. So you're going from negative 10 to negative 8, negative 6, negative 4. So you're increasing those values. So that means the slope of the first derivative is actually positive, which makes the second derivative positive, which actually forces your function to look concave up. So now let's try this out. So if I'm given an original function of g, I want to sketch the graph of the derivative. So I look at my function and see where my slopes are 0 first. So at negative 2, 0, and 2, they all are at local mins and maxes. So that means our slope is a minimum, or like our slope is 0 at those points. So I'm going to draw points on the graph that represent that. Now on the left side of negative 2, we're going down. So that means your slope, since it's decreasing, is negative. So I'm going to draw a line that is below the x-axis up towards negative 2 to touch it. Now after negative 2 to 0, we're increasing. So we're going to be above the x-axis, but I see that there's a point that is in between where it's changing from being concave up and then transitions to concave down after that. That is called a point of inflection. And so that point is the maximum or minimum slope value for that part of the function. And so it's like a peak or a minimum or a maximum. So I'm going to draw it somewhere above or below based on that. So I go up towards that point on 1 and then come back down to 0. I do the same thing to the right. There's a point at 1 where there's a point of inflection. So I'm going to go down and then come back up to 2. Then after that, there's a corner at 3. So it means it's kind of indeterminate. I can't take the derivative of it. So I have an open circle there to represent the rest. So then for example 2, I'd like you to pause and give it a shot. All right, now that you're back, the slope where it's 0 is at negative 2 and 2. So I'm going to plot those 2 points. Everything to the left of negative 2 is increasing, so my slope is going to be above the x-axis. Then I can recognize in between negative 2 and 2, there's a point of inflection at 0. So I'm going to graph where I think that point or that minimum slope value will be. Then I will continue my line to go down from -2 to that 0. But then after that, it comes back up, showing that it's negative. And then after that, it's increasing, so I go up. So that's my first derivative. Now I could continue this pattern and do the same thing for the second derivative if I'd like. And so at 0, that's when my slope is 0 for the first derivative. So I plot that point. Everything to the left is negative. Everything to the right is positive. So it actually turns out to be a straight line. And that would be the second derivative graph. And I could continue this, but the next one would be just a constant value because of that slope, since it's a line. Okay? Have fun.